Hello, good evening, everyone. Today we are going to solve the questions from week 8 content. Fine. So please join periodic. You will have to answer there only. We will solve some questions. There is a password on the screen. You can put that password and join. So let's start with it. Keep your pen and paper ready as we are going to solve the questions from CLT topic, central limit theorem. So you may need pen and paper. Okay. So let's start. Am I audible clearly?
Yes, ma'am.
Okay. So there is a first question regarding central limit theorem only. There are 100 random variables which are independent and identically distributed, whose expected values are 3 and variance is 9. We have to approximate probability that sum of these 100 random variable is more than 100 using central limit theorem. So try yourself, then I will discuss it. Fine. You can answer, like, no need to find the exact numerical value. Just in terms of FZ is fine. Okay. That is CDF of a standard normal random variable.
Ma'am, 1 minus fz of minus 20 upon 3.
Okay, just a minute. Haven't you joined that peer deck?
Okay, ma'am. Sorry.
Okay, it's text is available there, so you can type there and answer, write your answer there. Done?
Yeah, done, ma'am.
Yes.
Okay. So let's start it.
Ma'am, in the graded assignments of week 8, I solved the questions of CLT, but after putting the value of FZ, I did not get it how to and where to get that.
Okay. So there might be the values of FZ might be given there, right, in the graded
No,
assignments
ma'am.
at the
No,
top,
ma'am.
isn't it?
No,
It's
ma'am.
not given. Okay, okay. Then you have to check it from the table, normal table. If you don't know, then okay. Uh, when is the last date? It might be on Friday, right?
Tomorrow, ma'am.
Tomorrow. Okay. Do you know how to calculate the value of FZ from the normal table?
No, ma'am.
Okay. Let me just check. Okay. So,
Okay, ma'am.
yeah, let's start with this question. It might be like that in your assignments. We have given some values of FZ, right? So, if there is any calculation mistake, then that value might not be provided to you there at on the top. So,
Ma'am, no any value of FZ are there.
okay, okay, fine, fine. Uh, then okay, we will have a session, or I will, or like we will find how we will check how to find the values from the normal table. So this FZ values are nothing but the CDF of a normal random variable. Okay, so there is a table known as normal table. From there we find that values. Okay, fine. So with question number 1 here, we have given that there are 100 random variables x1 to x100, and all are IIDs, right? With mean 3 and variance 9.
9.
That's fine. And we were interested to calculate probabilities of sum of these random variables that has to increase, which increased by 100 from 100. Okay, so how we will use CLT here, central limit theorem?
We will first standardize the probability.
Yeah. So as these are the IIDs, so we can do one thing. By the way, what is central limit theorem? Why are we standardizing it to normal? Any idea? You might have attended yesterday's lecture, right?
Ma'am, because it is easier to solve in normal and sometimes we don't know the distribution, it can be converted into normal.
Okay, but here the only information given to us is these are some random variables with mean 3 and variance 9. Then why are we interested to standardize it into a normal
Ma'am, the
and then
calculation.
so there is a central limit theorem behind that. But do you know what is central limit theorem? So if there are random variables, let's say xi's are independent random variable, may or may not be normal, then central limit theorem says that once you have some good numbers of this random variable, then mean of these random variables, that means sample mean of these random variables, will converge to a normal random variable. That means irrespective, we don't know what are the distributions of xi's, but by scaling in a way, in a particular manner, when we sum up all these random variable, then that linear combination will converge to a normal random variable. So look here. This is nothing but the sum of a random variable, right? So we have two information. First, CLT says that if you have some numbers of random variables, then once let's say x1 to xn, as n approaches to infinity, then summation of this random variable divided by n will be a this will be a random variable, right?
Simple
That we
mean.
have discussed in the last session. Yeah, this is
It
also
will
a
be
random
simple
variable.
mean.
Sample mean, yeah. So sample mean is also a random variable, which is a function of xi. So central
Yes,
limit theorem says that once there are sufficient numbers of n, then this sample mean will have a normal distribution. So that's why we are interested. That's why while solving this kind of question, we standardize it to a normal distribution, right? So okay, so just denote this numbers. Let's say, because again and again we will avoid this writing this sum again and again. So I am just writing it as S100. Fine.
yes,
This
ma'am.
is my sum of 100 random variables. So what CLT says in terms of mathematical formula, if you put it into a mathematical, then
S100 minus
100 minus.
expectation of S100 upon root under variance of S100
upon
or a standard deviation of S100.
standard deviation of S100,
S100
this will follow.
normal 0, 1.
So it will follow a distribution normal 0, 1. So
Yes, ma'am.
now understand here. Once you do this, your task is very simple because S100 is there. You know how to calculate expected value of S100, and also you know that how to calculate standard deviation of S100, right? And then like the question will be easy. But now I am asking you another question. Why are you doing this kind of things?
Because of standardizing.
Standardizing to what? What are you standardizing? Like S100 is your random variable, and
Yes, ma'am.
you are converting it into a standard normal random variable, right?
Yes, ma'am.
Once you subtract your expectation and divide by a standard deviation to a random variable z that you might have studied previously, z minus mu by sigma square follows distribution what? Sorry, it's not sigma square, it's a sigma, right? If z is a random variable,
Normal 0.
yeah. So why do we do this? Because we have a CDF table, that is normal table for a mean 0 and variance 1. That's why we do this kind of things. Otherwise, if your z is following a normal distribution with mean mu and variance sigma square, then the calculation will become quite tricky. And for like for standard normal distribution, there are certain results that makes your calculation easy. So we convert it like that. Okay. So initially z was a normal distribution with mean mu and variance sigma square. So we converted it, we standardized it into a standard normal random variable. Fine. So here we are standardizing S100. But do you know, like, do you feel why are you standardizing it? Are you like, do you know that S100 is a normal distribution or not?
To find approximate distribution of this.
To find approximated, that's correct. That's fine. I'm just giving you idea how CLT is going to use here. What I said initially, that if you have some numbers of some random variables, let's say 100 random variables, then when you sum it up, sum this all independent and independent and identically distributed random variables, then that sum, I should not say sum, it might be, it is actually linear combination with certain scaling. Okay, so let's just say it sum. Okay, let's say linear combination is all the linear factors are 1. Okay, So this sum will follow a normal distribution. Do you agree? First, let me just tell. If xi's are your xi's are random variable, then do you agree that this sum will be a random variable? First question is this. We know that x1, x2, x100 are random variables, right? So can I
Yes, ma'am.
say that this s100 is again a new random variable?
Yes, ma'am.
Yes, right? It is nothing but the function of a random
Yes or no?
variable. So if s100 is a random variable, then once anything is a random variable, it have a distribution, right?
Yes.
It will have a distribution. What is the distribution of xi's that we know?
No.
No, it was not given. Just mean and variance was given about xi's. That's it. And they are independent. It also, this information is also given. Now, how do you know that this s100 is following a normal distribution? Because you are standardizing s100, right? See, isn't it similar to this z minus mu by sigma square? This is nothing but the mean of z. This is nothing but the standard deviation of z, right?
Yes, ma'am.
And same thing you are doing with the s100. I just clarified why we do with this. Why do we do this thing z minus mu by sigma to why do we do this thing? Because initially z was a normal distribution with mean mu and variance sigma square, but I have to make calculation easy, so I converted it into a standard normal form. Okay, but here I know that initially that my z is following a normal distribution, right? Z or X or whatever your random variable is. Now here you are standardizing S100, that is fine. But just give me a logic. From where did you get to know that this S100 is following a normal distribution with some mean and some variance, right? Did you get my question?
Ma'am, because of MGF, we can prove that it is following a normal.
Because of MGF. How?
Ma'am, because when everything means when we do the MGF, the end formula is the same as the normal MGF.
The N formula means? You are a little bit
Once we
you are
do
somewhat more or less correct, but I need the clear idea.
Ma'am, because when we standardize, after that, if we find out the function, then it will be similar to a normalized function.
Standardized means
MGF function will be similar to.
standardized will be later. Yeah. Standardization will be a next step. First, you have to be clear that your S100 is following a normal distribution. From where did you get that your S100 will follow a normal distribution?
Because
So,
this is mean, ma'am. This is mean of something is.
is this a mean? This is the sum of 100 random variables, right? Isn't it? S100 is nothing but the sum of all the 100 random variables. Then
Ma'am, each xi is a normal random variable, right?
no, it's not given.
Okay,
So,
then
ma'am, as per the after calculating the MGF of S, it will be same as that of the normal.
What? Please repeat.
So, ma'am, once we have done the calculation of S, means we have find the MGF of S, it will be same as that of the normal.
Okay, yeah, that is also a valid point. That says that there is a concept that says when we have x1 to xn random variables, as n increases, then your MGF will turn to
Approaches normal.
approaches to normal. Fine. The similar thing. This is what CLT also is like similar kind of thing that says whenever there are some random variables x1 to let's say xn, and as n increases, then you might have seen this that some x1 x2, and that this thing we have in our lecture, that divided by square root n will follow what?
Normal.
Normal with what? Mean and new will be there, right?
Zero
Well,
and sigma.
No, mu.
Zero.
Zero and sigma
Yeah,
square.
what?
0 sigma.
Yeah,
0 sigma square.
yeah. 0 sigma square. Fine. So that's why this S100 will follow a normal distribution with some mean new. That means nothing but the mean new and sigma square. What is our mean there? Mean is nothing but expectation of S100 and sigma square is what? Variance of S100. Fine. Did you got it? Like,
Yes, ma'am.
so that was the thing I have to discuss. Rest calculation, I think you will be able to done this calculation, right? Even though without knowing this stuff, you might be able to solve this question, right? So just
Can
be
you
careful.
explain once again, please? Can you just go through it once again?
See, we have n random variables, and CLT says once that n increases, the average or the scaling of your random variables will lead you to a normal distribution. Okay. So here in the question they have given that use CLT. That's why we are using CLT. Okay. Otherwise, in real life, this 100 number is very less to confirm that whether it's approaching it or not without knowing much about the distribution of X. Okay. So here in the question, it was given that use CLT. So we are assuming that, okay, this S100 is following what? Normal distribution with mean new and sigma square, variance sigma square. Fine. So what might be your variance? That is, sorry, what will be your mean? That is nothing but the expected value of S100. So yeah, what did you get for the expected value of S100? That is nothing but expected value of what? X1 to X100. So
100 into expectation of X.
yeah, I just by mistake wrote here mu and sigma. I should write expectation of xi and variance of xi. Okay. So this will be nothing but 100 times what? Expectation of xi, that is nothing but 3. So find 300. And what about variance?
Variance 3.
Root of n into sigma.
What?
Root of n into sigma.
Root of n into sigma. Why it is so?
Ma'am,
We are calculating variance, right? Variance of x1 plus x2 will be what?
9.
oh,
N
n
times
into variance of
variance
x.
of
Sorry,
x.
ma'am, I'm telling sigma. N into variance of x.
100 multiplied by variance of xi, right? Because we have 100 variables. So it is nothing but 900. Sorry, 9 multiplied by 100, right?
Yes, ma'am.
Okay. So
900.
yeah. So our standard deviation for S100 is nothing but
30.
yeah, square root of 100 multiplied by 9, that is nothing but 3 into 10, that is 30. Fine. Okay. So using CLT, what are we getting?
N minus
Yeah,
100 minus 300 upon 30.
okay. We need what we were okay. S100 minus expectation of S100 divided by standard deviation of S100 will follow a normal distribution, right? This is given by CLT. Okay. Now I hope why are we able to write this? Because S100 is following what? Normal distribution with mean and variance, this one. So our target is to calculate this probability, right? Probability of S100 is greater than 100, right? So how will we write it? We are interested to find the probability that S100 is greater than 100, right? So this is nothing but probability. I will just convert this S100 into this form, right? Isn't it? So what I will do, I will just subtract expectation of S100 from both the sides. So what I will get, S100 minus 300, right? It's greater than 100 minus 300, isn't it? Again, I will divide it with the standard deviation so that S100 minus 300 divided by standard deviation of S100 is nothing but 30. So this is 100 minus 300 divided by 30. Fine. Now, why I did these things? Because this S100 was following a normal distribution with mean mu and variance sigma square. But I want my variable to follow a normal distribution with mean 0 and variance 1, so that I can use the normal table and find the values accordingly. So now this random variable is following a normal distribution with mean 0 and random variable and variance 1. So yeah, this is nothing but probability. Can I say this as a some number? Let's say Z. Is it fine if I write it like this?
Yes, ma'am. Yes, ma'am. We
Okay,
can.
so Z is greater than what? This will be negative 200 divided by
20 upon 3.
negative 20 by 3. So how do we write this probability Z greater than negative 20 by 3?
1 minus fz of minus 20 upon 3.
So why this 1 minus there?
Because we need 1 minus probability of z less than equal to minus 20
Yeah.
upon 3.
Yeah. So I just told this is nothing but the CDF of what? Random variables. So CDF generally we give like this, right? Z is less or equal to A, then we say that it is nothing but the CDF of A, right? CDF of a random variable at a point A. Fine. But if I have the information that Z is greater than A, then I should write it as a 1 minus probability Z less or equal to A. Fine. So this is nothing but 1 minus probability Z less or equal to negative 20 by 3, which I can write it as what? 1
F of minus 20.
FZ,
of,
FZ of minus 20 by 3.
okay. So in examination or any examination like GET set, whatever exam you will appear, if this kind of situation will happen, then these values will be provided to you so that you will get the answer. But yeah, you should learn that also how to take the values from the normal table. That is also little bit tricky, but not that much. Okay. So that's what this was what probability that S100 is greater than 100. Okay. Fine. Any doubt?
Ma'am, I have a doubt. Actually,
Yeah.
for the graded assignments, we don't have the values given for this.
Yeah, someone has told this initially.
Yes, ma'am.
Okay. So
Maybe can
I
we
will
just
see.
solve for this, and can you help us with this, ma'am?
Ma'am, we
Okay.
can use another resource for website like.
Yeah, that's also
But
fine.
there
You
were
can
too
use.
many. But there were too many values, so get
No.
confused.
It's a normal table only. You just search standard normal table. That's it.
Yes, ma'am. Z
Ma'am,
table
Z value
also.
table, ma'am.
Z
Z
table,
value
yeah,
table.
Z table, yeah, Z table is also fine. Z
Ma'am,
table.
I also find, but the values are too many. Means the
No.
small values. Can you
No,
show
no.
ma'am it?
Can you show
How to check it from
It's
the Z table?
it's little bit
How to use
complicated.
Z
I
table?
will try to cover it if possible after at the end of the session. I will try if time permits.
Okay, ma'am. Thank you.
Okay. So fine. Let's move to the next question. So there are again 100 random variables which are following normal distribution with mean 0 and variance 2. Then find the probability that x1 square plus still x100 square is greater than 220. That means sum of squares of random variables. Using CLT, enter your answers up to 5 decimal. Okay, 2 decimal is also fine. See, here value is given, so they are asking you particular numeric value. Try it.
Ma'am, expectation will be 0 now for n is equal to 220.
For n is equal to 220. Why?
Because given is the normal of expectation 0, and if we calculate 0 into 220, then sorry 100, then it will be 0 now.
Just check it. Do you need the expectation of xi or expectation of xi square?
Yes, xi square, yes. For also it will be 0 now, because 0 square into 100.
Check variance. How do you calculate expectation of xi square?
Ma'am, it is maybe from chi distribution, something like that.
Yeah.
Ma'am, just asking one doubt. Here
Yeah.
the y is equal to x square 1 plus that series, the square series, right? That is the y.
Yes. Yes.
So, yeah, okay.
Do you need more time?
Yes,
Yeah,
no,
yeah.
ma'am.
Few more minutes. Maybe just 1 or 2 more minutes.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, sometimes, but this type of question becomes very easy. We know that fz is just 1 minus this, so we can directly plug in the value. We don't have to prove it something.
Yeah, that is also fine. But here, are you able to do that?
Yes, ma'am. I was able to do that also, but this is also another way.
Okay. Okay, we will discuss in some time.
But usually we'll get more than one value. We'll have multiple values.
No multiple values, man.
We will get this value only, right?
Yeah, there will be a unique value only. This is like maybe see
I'm
some
saying
normal tables are
different-
very much accurate. This decimal points. See, if you find a change, then changes will be this only. This 0.761115. Instead of 5, there might be 6 or 4, depending on accuracy of that table. Some tables will give you the values till 2-digit only, so then it will be a 0.76 only, but not a major change.
No, I meant like different f of z's. They'll have 3, 4, and we have to take the one that we get.
You mean do you mean if you change this value, then you will, then that's obvious, right? If you change this inside value, then this will change. See, there are lots of table. When you are checking with the table, just check whether you are checking with the Z table or not. There are T table, Z table, chi-square table, and so many. So just be careful.
I didn't. I meant like in the exam, in the quiz, we'll have 5, 6 different values given, and
Yes,
what
yes, yes.
we get in the
That
exam,
might be
we make
using,
it, so
yeah.
we cannot use directly 1 minus this value.
Yeah, yeah. That various values are given so that it may be possible that these values are needed to solve in the paper. That's why. So okay, done. Should we start the discussion?
I got one, but not sure if that answer is correct.
Okay, let's just check it. So here, what was the challenge in this question? There are 100 random variables, and they all are IIDs with and also distribution is also given that normal 0,
Is the
2.
expectation will be 200?
Sorry, expectation will be
200.
expectation of what?
Y means the summation of x1
Summation square. Okay, okay. Just let's check it.
Yes, 200.
Okay. So this is a normal distribution. So yeah, one more additional information is given compared to the last previous question, right? And we are being asked for the question that x1 square plus x100 square is greater than 200. Okay. So those who might have covered the topics from the week 8, they might know one result, you know.
Distribution.
If xi's are following independent normal distribution with mean 0 and wherein sigma square, then xi square will follow
Gamma distribution.
gamma distribution with what?
1 by 2, 1 by 2 root
1 by
sigma
2
square.
sigma square.
100 square will follow gamma distribution with
1 by 2, 1 by 2 sigma square.
1 by 2, 1 by 2 sigma square. Are you sure?
Yes, ma'am.
It is n by 2.
n by 2, ma'am.
Yeah, n by 2. Okay. So here your n is nothing but 100. So for us, this x1 square to x100 square will follow a gamma distribution with mean 100 by 2 and sorry, this is not mean, alpha 100 by 2 and beta 1 by 2 sigma square. But okay, we do not need this. Why? Because in the question they have asked us to use CLT directly. Fine. This
Ma'am,
was
I
the
have find the expectation of summation of squares by using the variance formula. First, I
yeah.
calculate the
Yes.
expectation of x1
So
square,
yeah.
then I multiply with 100. I got 200.
Okay, that is also fine. You can use that formula in a easy way also. See, we have given that xi's are following IID with normal, with mean 0 and variance 2. Fine. So we know that expectation of xi's are, yes, someone was saying 0, right? Expectation of xi is 0 and
Yes,
variance of xi is
2
2. So how to calculate expectation of xi square then?
variance of xi
Yeah,
plus expectation of x to the xi to the whole square
variance of xi minus plus
plus ma'am
expectation of
plus
xi
xi
square
to the whole square
square. So it will be 2. Fine.
2 plus 0. Yes,
Expectation
ma'am.
of xi square.
Then
Okay.
multiply with 100.
Yeah. So what will be the expectation for x1 square to sum till x100 square? What will be? So expectation get separate over addition associative. So this will be 2 into 100. Fine. So 200. How to calculate variance of xi square? How did you guys calculated this?
Alpha by beta square.
Alpha by beta square. Okay, great. Yeah, alpha by beta square. That is also. Then what did you get your answer?
Ma'am, we
Alpha
will
is
get
here. What?
8. We will get 8.
Okay. So yeah, that was the use here, that if you know that your xi's are following normal distribution, then xi square will have a gamma distribution. That was the use here. You have this alpha and you have this beta. Even you can find mean from this alpha beta, right? What was the mean of gamma distribution?
Alpha by beta.
Alpha by beta, correct. And what is alpha here? N by 2. That is nothing but 100 by 2, right? And what is beta square? 1 by 2 sigma square, right? Yeah.
Yes.
So this is nothing but 50 divided by 1 by 2 sigma square. That means 1 by 4.
1 by 4.
Yes, ma'am.
Then
200.
it is 200. Fine. And what if we calculate alpha by beta square?
We will get 800.
800.
Yes, ma'am.
It will be 50 divided by beta square is what?
1 by 16.
1 by 16, ma'am.
1 by 16, which is equal to 800. Yeah. But this should not be happening.
Ma'am, how do we calculate without using this formula of variance?
Okay. Yeah, fine. So variance can also be given by, see, whenever your xi follows a normal distribution. So let's say x is following normal distribution with mean 0 and sigma square something. Then your variance of xi square will be given by, yeah, and do anyone knows that? This is 4 sigma square.
Ma'am, it will be.
Sorry. Yeah.
It will be sigma square only, right? Because it is identically distributed. Acha, for square, xi square.
4 sigma square, and we get it as a 8. That is 8. Fine.
Ma'am, why did 4 come out?
Yes, ma'am.
Yeah, that's what that like
Ma'am,
it follows a chi-square
ma'am,
distribution, and from there it came. Yeah, but I think
ma'am,
here something missing. Yeah.
properties of variance is that if we multiply variance with means if we have variance of x is 2, and if we want to find the variance of 2x, then it will be 4 into variance of x.
Again,
But
please
here
repeat.
it will,
No, it is
ma'am,
actually 2 sigma power 4. Yeah.
if we have, let's say take an example, if we have variance of x is 2, and if we want to calculate the variance of 2x, then we will find it by 2 into 2 to the power 2 into variance of x, no? But
Yes.
here it is not any this, because we will find the variance of x squared, not any coefficient.
Yeah. If it was a constant, then you can just take it outside 4 times variance of xi, right? Like that.
Yes,
But
ma'am.
this was not
Then how
4.
do we
That
find?
was my mistake. It was 2 sigma square, 2 sigma to the power 4. So actually, there is see, there is a what we say, a concept which says that whenever your x follows a normal distribution with mean 0 and variance sigma square, then this x square by sigma square follows chi square 1. Okay. And from there we get to know that variance of sigma square is 2 sigma to the power 4. So that's a different story. We should not go to there. I don't think so. It's in
Okay,
your
ma'am.
syllabus. But yeah.
Ma'am, so without using chi distribution or without using gamma distribution, we cannot find out variance of xi square.
Yeah.
Okay.
So yeah, that is and you can use it, but I don't think so. If you know how to play with the covariance, then also you will be able to. But that is also somewhat tricky. But as of now, if you know that it's following gamma distribution, then it's easy to find the variance of xi square. So okay. So now what we have, we want to calculate probability that x1 square, x2 square till x100 square is greater than what? 220 it was asked, right? And we have to use CLT.
Yes, ma'am. Let's take
So,
this z.
yeah, using CLT. So let's consider this one as not a z, because this might be following normal distribution with some mean, with some variance. So I will just, okay, just take z, that is also fine. Okay, just take
Yes,
it z. Then using CLT, what will happen? This
z
z
minus
minus
expectation of x
expectation of xi square, that was what? Okay, expectation of z I am saying, okay, divided by
upon standard
standard
deviation.
deviation of z is greater than, is following what? Normal distribution with mean
0,
0
1.
and variance 1. Fine. So while calculating probability z greater than 220, we will do the same thing that we have done just here, just before this question, right? What was expectation? 200, right? And
Yes, from
standard
200
deviation,
upon root 800, which will be
square
28.28.
root of 800. Yeah, that is greater than 220 minus 200 divided by square root
On
of
root
800.
800.
Fine. So
Yes, ma'am.
this is going to follow a normal distribution with mean 0 and variance 1. So we will have what? Z minus 200 by square root 800 is greater than, this will be 20, and 20 by square root is fine. Yeah, 4.
28.28,
400
ma'am.
into 2, right?
Yes, ma'am.
So it is nothing but 1 minus, yeah, what?
1 upon root 2. 1 upon root 2.
So that why I was not writing it Z. Let's say Z1 it is. Or fine. Let's take this one as a Z. Z1 F Z of Fz of what? 1 by square root 2.
0.707.
Yeah, that was given there. So it is 1 minus Fz of 1 by square root 2 will be 0.70, right? You might have calculated from calc. And the rest of the part is just a subtraction, and just subtract that 0.76, so we'll get something around 0.24. But we need answer in 5 decimals, so I'm just writing it directly. Okay.
Ma'am, if in the question they say after the 5 decimal, then we will take always, means in the calculation part we always take the after the point we take the 5 value, no? In all
Yeah,
the
it
steps.
just look at the question. If they are asking till 2 decimal, then no need to calculate that much. Just round
Yes,
it to
ma'am.
2 decimal. That's also fine. So here it was sigma of xi square, and then variance of x1 square till x100 square will be 100 times 8. Okay. Just one correction there. Yeah, this was summation of xi square, because this summation xi square was following gamma distribution. Okay. So here in this particular one, it was actually discussed in the what we say our lectures, that if your xi's are following normal distribution with mean 0 and variance sigma square, then summation of xi square will follow, and they are independent also. Sorry, independent and normal. Then summation of xi square will follow gamma distribution with mean n by 2 and variance 1 by 2 sigma square, right? So this was given there. So we have used that. So this is our alpha and this is our beta. So this summation xi square is a random variable. Now, if you know alpha and beta, you can easily find out mean of this random variable summation xi square, which will be alpha by beta, and variance will be summation xi square. Variance is what? Alpha by beta square. Okay.
Beta square.
We just used these things, and after that we used CLT as it was given in the question, that we have to use central limit theorem. Okay. So this was whole summary for this question particularly. Okay. So is there any doubt?
Ma'am, can you write the distribution of chi square?
Distribution of chi square is given there, right? Why do you need that? Like that's somewhat 1 upon pi square. It's tricky. Yeah.
Ma'am,
I did not get it, ma'am.
In PPT, we have there in chi-square distribution. I think in this question also we will get the chi-square distribution. But here in this particular question, we do not need the chi-square distribution.
Okay.
That I was talking about, that was a different story. Like that is one of the way how we can reach to variance of the normal distribution, variance of xi squares. Okay.
Okay, ma'am.
That was another way, but here if you know the simplest way, that if xi's are following normal distribution with mean 0 and variance 2, variance some sigma square, then the summation of xi square will follow gamma distribution with given alpha and beta. Okay. So here the question can be tricky if they use instead of this mean 0, it may be possible that in some examination they put non-zero mean, but rest of the thing. So be careful whenever you apply that gamma kind of thing. That means what I said about this result, where it has gone. So just be careful. First, your task will be to convert your mean into a zero mean. How will you do that? If it is given that, let's say, your xi's are following normal distribution with mean nu and sigma square, and asked about the summation of xi square, like the same question, probability xi square is less or equal to 220. Then what will you do? Then in this case, you cannot directly use that this will follow, this summation xi square will follow gamma distribution. No, then it will be a wrong. First, you have to convert this thing such that its mean get converted to zero. So what's the criteria to do that?
Ma'am, first we'll centralize the distribution.
Yeah, if you speak one by one, then only I can.
Centralize the distribution, ma'am.
Yeah, centralize the distribution. That is nothing but subtract all the values of xi from mean.
Mean.
That is just a translation of your distribution. That's it. Okay. Then after that, you use a gamma distribution kind of things. Okay. So let's move to the next question.
So, ma'am, we can just subtract it by the expectation, or we have to divide by standard deviation also?
If you just give me one answer. If you subtract something from its expectation and divide it to standard deviation, what do you get?
Normal
that
0,
is
1.
one of the thing to, if you, whenever you divide with the standard deviation, you also control your variance also. Okay, so whenever there is a need to control your variance, you can divide it with the standard deviation. So to apply this theorem or result, which says that xi's are following normal distribution with mean 0 and variance anything, at that time we do not need our variance to be 1, right? So that's why we will not divide it by standard deviation. Okay.
Yes, we'll just subtract by the expectation.
Yeah, that's it. That's enough for us. Even though if you divide it standard deviation, then this will become 1, and as such there is no use of that, right? Like in that case also your answer will be same, just variance will get changed. That's it. Okay. So there's a question number 3, which says that x is a random variable having the gamma distribution with alpha is equal to n and beta as 1. Okay, and the expectation and variance of x is given there. Using weak law of large number, find the value of n such that probability that x by n minus 1 is greater than 0.01. Okay. So this one is also, this might be easy for you. Expectation is given there, variance is given there, and we have learnt weak law of large number also, right?
Where this solution will be uploaded, in which section?
Yes. Actually, solutions are given in this PDF only.
No, where will be it uploaded? In which folder?
In your portal.
In a peer deck slides?
Yes,
supplementary contents.
it will be in a PDF format.
Okay.
In supplementary content, yeah.
Okay.
Solve with instructor session is there.
Okay. Solve it.
So do you have any idea how to start with this question?
Yes, ma'am.
Yes, ma'am.
Okay, then it's fine.
Ma'am, just to clarify, means one of the way we can take this 1 as the mu and equate it to the expectation.
Yeah.
If we replace that n in the calculation, it is getting cancelled. No.
Okay, the hint is just take this capital X as a sum of some random variables. But how many random variables you will take? Just recall first weak law of large number format. What it says? Weak law of large number. Do you remember?
Yeah, that 0.01 is equal to sigma square by
That your sigma square, that is your delta square. That's fine. But what it was like the main format, modulus of what?
X bar minus mu.
X bar minus nu, right?
Yes.
So that was the hint. X bar. X bar. What is X bar? Sample mean. How
Yes.
do we write sample mean? Sum of all the random variable divided by number of random variable. So if I said capital X, take capital X as a sum of random variables, then how many random variables will you take?
That we have to find.
Yeah, that is given actually. Yeah. That is the question. Yeah. How many random variables are needed? And just take x1 to xn, okay? Still any doubt regarding this? How to start this solution?
Is it 1?
What?
This answer. If we can we compare this?
Answer means you are taking the question is to find the value of n, right?
Yeah.
So you are saying that only one random variable.
Just if we compare this x by n, that is the mu, right?
Yeah.
And this is given that it is alpha by beta, right?
Yes. X by n. Yeah. Okay.
Ma'am, it is 100,000.
100,000.
I'm getting 10,000.
Okay. So haven't you replied on the response sheet? As I can see, it's no response till now. So whatever the answer is, just put there. We'll discuss it.
Ma'am, isn't the sum of gamma distributions exponential?
Gamma distribution exponential. So what you are talking about, do you know what the things are required for that?
Yes, ma'am. IID, NIID gamma distribution, sum of that is exponential.
NIID gamma distributions. Any restrictions? Do you remember on gamma? Any restrictions on it, or
No, ma'am.
so if yeah, but sum, right? Sum of
Yes.
sum of n. So what do you said? Can you please repeat?
Sum of NIID gamma distribution where alpha is equal to n, it is exponential only. Exponential beta.
No.
No, ma'am. Sorry, ma'am.
You are like confusing with, you got confused with this. Sum of n IID exponential distribution having parameter as a beta is a gamma distribution with alpha beta.
Okay, ma'am.
With n beta. Okay. So that's why I questioned you.
Yes,
Yeah,
ma'am.
someone was speaking here. What happened? So if there are n independent exponential distribution with parameter as a beta, then the sum of your n random variable will follow a gamma distribution with alpha which is equal to n and beta as beta itself. So generally there are very less results which starts from the gamma. They will lead to gamma distribution. They will lead to Cauchy square, like that. So okay, let's start with this. Okay, still no response, I think. Haven't you joined this peer deck? Okay, it's there. So let's start with the solution. So what we have given there is there are what n random variables, right? How much random variables are there? That is the only question here. So x1 to xn we have. Oh, it was not given. Just x is a random variable they have given, right? X is a random variable having a gamma distribution with parameter alpha is n and beta as 1. So is it fine if I write it like this? Gamma distribution with what alpha is n and beta is 1. So okay. So you need your alpha is n and beta is 1. Okay, that's fine. And using weak law of large number, we have to find the value of n. So see, in there are many ways to find n, but they have asked you to calculate this thing from weak law of large number. So anyone knows what is the use of weak law of large number? Like for CLT, I explained, right?
If
CLT
sample
for,
mean is how far from the actual mean.
sorry, yeah, what?
Sample mean is how far from the actual mean.
Okay.
Ma'am, when the n increases, it falls to predict the probability.
No, it is to know. It is to know what should be the sample size.
Yes, yes. This question is about what should be the sample size. Yeah, correct. And what he said about the weak law of large number is also correct. It shows us the difference between the actual mean and sample mean. Once they collide, this is once n increases till a sufficient number, at that time the sample mean will approach to your given mean. Okay. So here from this also we can have nu as 1 and see weak law of large number. What was its format? If I write it as WLNN, it's the weak law of large number. Okay, I just number. Okay. What it says, weak law of large number, probability of what?
Modulus of
X
x
bar
minus greater than
is
delta, which is less than or equal to sigma square divided by n delta square.
okay, fine. So sigma square and delta square we know. The question is about this n, right? So what is x bar there? x1 to xn by n, right? So now from here you can take the hint that there are n random variables x1 to xn. So this capital X is nothing but the sum of x1 to xn. Fine. If I write it like this, is it fine for you? We have
Yes,
to
ma'am.
let it. Okay. Using this expression, we are taking capital X as a sum of n random variables. Okay. And they are following gamma distribution. It is given that this capital X is following a gamma distribution with mean, with alpha is equal to n and beta is equal to 1. Yeah, this was given, right? So just tell me, what should be the alpha and beta for this xi, so that when I sum this gamma distribution, it will give me a n alpha as n and beta as 1. So do you remember one thing there? That summation of, let's say, there are these n n random variables such that these xi's are following gamma distribution with what should be the alpha and what should be beta here, so that when I sum them, this alpha becomes n and beta becomes 1. So you might remember that if these xi's are following alpha beta, then what might be the distribution for capital X? If I am taking it as a 1 1, then you may remember that this sum will follow what? Anyone know about this?
Exponential. Exponential.
No, not exponential. That's a different result.
Gamma distribution with n alpha beta.
Yeah, these are the gamma distribution with alpha as 1, beta as 1. Then if I sum up all such random variables, then that sum will follow the sum of all these random variables, sum of all these alphas. So how many alpha are there? How many alpha are there? So n times, right? So n alpha, and what will happen to beta? It will simply remain as, yeah,
Beta.
it will simply remain as a beta. Okay. So this is alpha and this is beta. This beta will not change. That's kind of result that we have discussed in lecture also. So what is alpha here? Alpha is 1 and beta is 1. So can I take it as n comma 1? So
Yes.
does it match with the given information?
Yes, ma'am.
N comma 1, right? Sum is following gamma distribution with alpha as n and beta as 1. So half of the problem is solved here just by observing this kind of things. Now, so this is nothing. Yeah.
So, ma'am, we assume that each xi is following gamma 1 1.
Yes. Yes, correct. So this is one thing. So now you can calculate mean of xis and variance of xis, right? What will be the mean of xis? It will be alpha by beta. So that is 1 by 1, that is equal to 1. And variance of xi will be alpha by beta square, that is n, right? So what is alpha there and what is beta there? 1 1. So again 1. Fine. Is it okay till now? This
Yes, ma'am.
expectation, this variance. Okay. So what do we need here to use weak law of large number? So delta is given there. What is delta here?
0.01.
0.1.
So this 0.01 is our delta. Here is a mean. You can take hint of mean from here also. And this n square and delta square is also. Is it? Can I write it directly like this, or I have to do something else?
Ma'am, go step by step, ma'am.
Okay. So if expectation is there and variance is there, and now I want to use weak law of large number, what is weak law of large number then? It says probability that x1 to modulus of x1 to xn divided by n minus nu is less than, sorry, is greater than what? Delta.
Ma'am, you wrote 1 instead of n.
Oh yeah, sorry. This is greater than delta is what?
Sigma
Less.
square by n delta square.
Yeah. Sigma square by n delta square. So do we have sigma here? What is sigma there?
0.01.
1.
So what about x1 to xn by n? This is x by n here, right? In this particular question, this is x by n. Fine. And what is new there? 1. Okay. So should I write it? X is nothing but x1 to xn summation, and nu is equal to 1. Delta is what?
0.01.
Delta is 0.01. So according to the weak law of large number, what should be this term sigma square by n delta square? This should be sigma square by n times delta square. Yeah, what?
Sigma square by n should be the variance of the sample mean, which is 1.
Yeah. So just take it one by one, step by step. Okay. So if I want to calculate x by n minus 1 greater than 0.01, this is my delta, right? 0.01 is delta. And now I know that by weak law of large number, my question will reduce to these things, right? 0.01 square. Is it fine if I write like this?
Yes, ma'am.
Any doubt here? So what is sigma there? We have calculated that also. Variance of xi is
1.
1. So may I replace this sigma by 1? Yeah. So now what will you do next? So
Ma'am, now we
given
will
that,
the
yeah,
last thing to 0.01.
what last thing?
The very last means one n sigma square by 1 by n sigma square sorry delta square to 0.01.
You will equate it or what?
Yes, ma'am, we equate it to 0.01 because in the above thing we have been given that it is equal to 0.01.
Fine. So equating will not work, because when you equate, that means after that, see, that is the only point. When you say I will equate it, then the thing is I'm thinking that at this particular point only this distribution will converge to the mean, actual mean, but that's not the thing. After that point onwards, my distribution will lead me to that mean. So just consider what has given to you. Again, I'm given where it was. Yeah, this one. See, it is given that probability that x by n minus 1 greater than 0.01 will be strictly less than 0.01. Fine, this was given to us. So, by weak law of large number, I got this quantity is strictly less than 1 by n, 1 by n into 0.01 square. So, can I write it as a 1 by n into 0.01 square is what? Less than 0.01. Is it fine if I write this? So just take. It was given that probability that modulus of x by n minus 1 is greater than 0.01 is strictly less than 0.01. So actually we were given with this value, right? That this value is at max 0.01, right? That is the meaning of this inequality.
So we are comparing this.
Yeah, we are comparing this. So we have given that by weak law of large number that this quantity will take at max 0.01. But when we applied weak law of large number according to the given parameter, we came up with this inequality that okay, this will take at max this value. So given that this value will be at max 0.01. So do you agree that we can write this?
Yes, ma'am.
Okay. So by just shifting your 0.01 square to there, what we will get 1 by n is less than what? 0.01 cube, right?
Yes, ma'am.
That's fine. So what is the value of n then?
Ma'am, it will be 10
10 to
lakh.
the power 6, ma'am.
10 to the power 6. Fine. What will be the sign?
N is less than 10 to the power 6.
Less than or greater than?
Greater than, ma'am. Greater than.
Greater than.
It will be a greater than. Okay. So how many random variables do you need to your actual mean and sample mean to come closer to 0.01 is 10 to the power 6, right?
Ma'am, how is greater than
Sorry, far. Yeah. Sorry, how is?
N is greater than 10 to the power 6. It is less than 10 to the power 6. Ma'am.
Okay, once you reciprocal the term, then what happens? Then it get reverse. Why it is so? So just consider this kind of things as like, okay, just tell me 1 by 2 is less than 1, correct?
Yes, ma'am.
Okay. If I take a reciprocal on both sides, then what will happen?
It's wrong, ma'am.
Yeah, then it's wrong. Why it is so?
Then we have to inverse the sign, ma'am. Yes.
So that are some inequality kind of things.
Yeah.
Okay.
Okay.
So fine. The n is greater than 10 power 6. That was our number. So there is next question. Continuation of this question. So did you guys understood this question? Its solution also?
Yes, ma'am.
Yeah.
Okay. So let's move to
Ma'am, how many questions are there in total?
6. Do you have class today also at 8 p.m.?
Yes, ma'am. Yes, ma'am. Maths
Okay,
too.
okay, fine. Fine. So this is the continuation of this question again. That alpha is n and beta is 1, x is a random variable. Now use CLT. That's the next question. So maximum thing we have done there, right? So now the task is to use CLT here. So do you get to know that what is the difference between last question and this one?
No, ma'am, I didn't get it, ma'am.
So see, initially when I was introducing that question, I told that if inequality is given to you, there are many ways to find this number n, right? So in previous question, we were asked to solve the question using weak law of large number. Here we have to find the value of n using CLT, central limit theorem. Okay.
Okay.
So more or less same thing. The hint is you just so whenever we use CLT, we assume that the sum of our random variable is following what? Normal distribution, right? So try to convert in that format so that your capital X is sum of random variable and whatever there is on left hand side, that is modulus xn minus 1 will
Ma'am,
become
in question, anywhere digit does not mention that x is a sum of the random variable. Then how you can say that?
okay, as we discussed in question number 3.
Hmm.
See, we have given that alpha is taking as value n and beta is taking value 1. So we discussed there that if I consider assumption, I will take an assumption that capital X is nothing but the sum of n random variables which are following a gamma distribution with alpha is equal to 1 and beta is equal to 1. Then if I have such a n gamma distribution random variables, then the sum of that random variable will follow a gamma distribution with parameter alpha as n and beta is 1. Okay.
Okay.
Okay. Were you there when we were discussing that question number 3? The same logic I am using here.
Okay.
So that is the reason in today's session there are not lots of questions, only limited, but they are conceptual questions.
Ma'am, one more doubt. When it is absolute value, so we will take minus 0.01 and 0.01 on both the sides of this absolute value, right?
Yes. So just double it. It will give the same, like it's equivalent to double it. Why it is so? Because we are assuming that the resultant distribution is going to follow a normal distribution. So once you learn this hypothesis things, at that time you will get to know that why such a things get double. It's not introduced, right?
No, ma'am.
Obviously, it's like CLT is going on, so maybe in next week. So do you know the distribution curve for the normal things? It's a symmetric bell curve, right?
Yes, ma'am.
Yeah, that is the reason why we double it. Okay. So you have lecture at 8, so I'm trying it, okay? So just remember, from weak law of large number, we got n should be greater than 10 raised to the power 6. Now our task is again same. We want to find the number of random variable so that it will converge to a given mean. So this portion is again same here, that let us consider that there are n random variables which are following gamma distribution. Yeah, which are following gamma distribution with mean, sorry, alpha is 1 and beta again 1. Yeah. Okay, so we assume that first it was our assumption, then from this result that if there are n random variables which are following gamma distribution with alpha as 1 and beta as 1, then their sum will follow gamma distribution with alpha as sum of these alpha and beta as it is. Okay, so we will use the same thing here again. So after that, using CLT, what will you get there? Any idea how to use CLT? So we know that again expectation variance.
Ma'am, first we'll find expected value of x.
Okay. So expected value, okay. Not needed that much, but let's see. Probability of using CLT, that means what? Yeah, we need that whatever the sum is, that should follow a normal distribution with mean 0 and variance 1, right?
Yes.
So probability that sum means here it is x. That means x minus its mean and divided by its standard variance should follow a normal, so that we can use a standard normal table. So it was given that x by n minus what it was 1, right? Greater than 0.01 is strictly less than 0.01. This is given, right? And
Yes.
they are saying that use CLT here. That means what our task will be to convert this such that we can find, yeah,
Maybe
yeah,
it is standardized, ma'am.
standardize it. Okay, using CLT. So how to do that. So just let me just write probability that x is nothing but what? x1 plus x2 plus xn. How can I write that? Rest of the things are same. Do you agree that I can write this x as a summation of x1 to xn?
Yes, ma'am.
Okay, then why? The reason behind that is I have assumed that x is x1 to xn, and this given information that capital X is following gamma n comma 1 has validated it, right? So I can write x sum of xi's in place of x. Okay. Now what to do so that this term becomes Sn minus mean of it divided by variance of it.
First, ma'am, we will write the modulus in another form, and we will provide, we will give 1 to each of the sides, and then we can do it.
Okay. Sorry, please repeat what you said.
First, we will write the modulus in another form, and then we will give 1 to each of the sides, and then we will apply the CLT.
Okay, that is also fine. One more thing. Do you remember that our mean was what? 1 and variance was 1, right? Mean of xi is 1, variance of xi is 1. Fine. So if I take Sn as x1 plus x2 plus xn, I know that my expectation of xi is 1, right? My variance of xi is 1, right? Why it was 1? Because my xi's were following gamma distribution with alpha beta, right? With parameter alpha comma beta. So this expectation and alpha beta was also 1 comma 1, right? Comma 1. So my expectation of xi is what? Alpha by beta. And what was variance of xi? It was alpha by beta square. Fine. So if they are 1 1, then just tell me what will be the expectation of Sn?
N.
N, okay. And what will be the variance of Sn?
N.
N again, okay. Is this fine for you? So I will just replace all these things here. So my next term will be Sn by n minus 1. This modulus thing, sorry. This modulus thing will be there is what? Greater than, sorry. Yeah, it's greater than 0.01. Strictly less than 0.01. Fine. So how to rearrange it? So now the rest of the thing is just a rearrangement. I want a denominator. What do we need there? Standard deviation, right? What will be the standard deviation of Sn?
Root
Yeah,
n.
anyone? Sigma of Sn will be square root of n, right? So here I want square root n, here I want n. So actually I want Sn minus n upon square root n, right? How will you adjust it from here? So not that much difficult. Just write it like probability Sn minus n by n, fine, is greater than 0.01, is less than 0.01. Any doubt doubt in this step? I just cross multiplied it, fine. So I got mean here, but this is variance. I want it to be a standard deviation. What to do? Just a simple mathematics, nothing there. May I write it square root n into square root n? Fine. Is it fine if I write n as a square root n into square root n?
Yes.
Okay, then what will be my next move? I will shift 1 square root n from here to here. Fine.
Yes.
Everything is correct mathematically now. So now compare it with our CLT. Sn minus n divided by square root n. This is our mean, this is our standard variance. So, and this is greater than some value. What should it be? Probability that modulus of z is greater than 0.01 square root n. Fine. Is it fine if I write z?
Yes, ma'am.
Okay. Now it's a modulus z, so we just double it. Probability z greater than 0.01 square root n. Okay. Fine. Now then next, this will be 1 minus fz of 0.01 square root n. 0.01. Okay. Then next, if we solve it, this will get in division and then addition. Okay.
It will become minus fz 2 into minus fz of 0.01 root n less than 0.0.
What?
No, nothing.
Okay. So if we move it, this 2 here, that will be under division and then this addition. So this will convert it to fz of square root n should be greater than 0. Yeah.
995.
995. Okay, fine. So 0.995. Now in the question it was given that fz of 2.58 is equal to 0.995. It is given, okay? That means I can
Ma'am,
write
how last two step it does?
this one.
Yes, ma'am.
Okay. I just did what I did. Yeah, fz of 0.01 square root n. This is 1 minus. Okay. I just first divided it by 2. Okay. Then I subtracted 1 from both sides and reversed. Is it fine or should I elaborate?
Subtracted or add, ma'am?
What should we do?
You subtract or add something.
We subtracted it.
Yes, ma'am.
What will I do? Fz of, this will be a small term, no?
Yes,
Sorry,
ma'am.
a larger term. Fz of 0.01 square root n. I just shift these both terms
Yes, ma'am.
here.
Yes, ma'am.
Okay, fine.
Yes, ma'am. Fine.
Okay. So that was all about that things. Fine. So it was given. So what can I write here? That fz of 0.01 square root of n is greater than fz of 2.58. Is it fine? If it is given that this is nothing but fz of 2.58, am I able to write it right? Okay. So once both the side there is fz values, what can I do? This will be nullified, right?
Yes, ma'am.
0.01 square root n is strictly greater than 2.58. Now I think from onwards you can do that, right? So squaring on just this square root n is greater than 2.58 upon 0.01. What will you get here? Yeah. 2.58 divided by 0.01.
58.
What's the result? It's 258. Okay. Just square it. That's it. N is greater than 258 square. And
6556.
yeah, what? 6564. Okay. So this N we got from the CLT. Okay. So just check when we used a weak law of large number, N should be greater than 10 raised to the power 6. And here what we got? N is greater than 66564. So can you just tell me which one is better approximate, which is going to converge fast, CLT or weak law of large number?
CLT.
Okay. So that is also one of the reason why that previous theorem is named as weak law of large number. Okay. So that is another story. So I will not start that. So next question is about suppose speed of vehicle on a particular road are normally distributed with mean 25 mega per hertz, sorry, mph, and standard deviation is 3. Find the probability that mean speed is 30, randomly selected vehicle is between 24 and 27. Okay. So I think can do it, right? Will not be that much calculation here. So even though you just decode the variables, na, that is also fine, because the rest of the portion is just calculation part. So so whenever there is a question, just ask yourself whether are you able to decode that or not. That's it. So here, what should be n here? If x bar is, that means sample mean is there. That means it is a sum. It is the average, right? Average of some n random variables. Do you know what will be the value for n here?
Ma'am, n is given to us 30.
Yeah. And what is this 24 to 27? That is the range of x bar, right? So we are required to calculate probability that x bar is lying between 24 to 27. Then any hint there?
Delta is 3.
What is delta? Like, do we need that?
Done, ma'am.
Okay. Should we start?
Yes, ma'am.
Okay. Aren't you guys putting your answers on peer deck? Okay, I have just extended the time limit. Those who want to put, they can. So, okay. Yeah, how to start? So we have given with the n is 30, right? And the question is find the probability that this x bar is ranging between 24 to 27, right? Is this clear? The question is the question clear to you?
Yes,
24 to 27, fine. Then what we'll do? Also given that nu is what? 25, and sigma is 3.
3.
Right? It's a sigma, not sigma square. Standard deviation was given. Okay. So x bar will be what? x1 to x30, right? Divided by 30. Then just tell me, this is mean and standard deviation of what?
Of the original distribution.
Xi or x bar?
Xi.
Okay, so may I write it as xi? What will be the mean of x bar?
25.
Why 25? This is nothing but the expectation of summation of xi is, that is 30 multiplied by 25, isn't it? X bar.
Ma'am, it will be say
Yeah.
sample.
Yes. For sample mean it will be same. Sorry. Mean of x1 to x2 to x30. Let's say it as a capital X, fine. Or let's say capital Y. Okay. The sum of x1 to x. Yeah.
Ma'am, but we know that sample means expectation is as same of that of the original mean.
Yes. That sample mean is 25. That's correct. I have changed it to just sum of 30 random variables. Did you got me? The sample when you
doing it because we know that the random variable is x bar only, so we don't need to do that.
okay, just wait. We will need it. Okay, fine. So let's start without it. Fine. Probability that your x bar should lie between 24 to 27. Fine. So what will you do? X bar is what?
25. Sorry, x bar is the sample.
X bar is the sample mean x1 to x30 divided by 30 is less than 27. Fine. Now what next?
Now we will use CLT.
Using CLT. Okay. So to use CLT, we need that this has to convert like what CLT says, that sum is following normal distribution. That means this part should get convert to Z, right? What we say as a Z of Sn minus expectation of Sn, right?
Yes, ma'am.
Divided by sigma of Sn. So what is Sn here? Sn is nothing but S30, right? X1 to X30, fine. Okay. So then next, what to do?
Expectation is 25.
Yeah, expectation of S30. Is it 25 or what?
Yes, ma'am, 25.
Are you sure? Expectation of S30 is nothing but the expectation of X1 plus X2 till X30. And expectation of Xi is 25. So it should be 30 into 25, isn't it? See, expectation of Xis are 25, no?
Yes, ma'am, but when we divide it by 30, we'll get 25 only.
But we are calculating the expectation of S30 only, not dividing it now.
Yes, ma'am.
So the question is just the expectation of S30, that's it. So
Okay,
expectation of S30 will be 30 into 25. What will be the variance? That means sigma Sn. Let's just calculate sigma square. What will be it? Variance of x1 to x30, yeah. This will be
900 into 30.
30
Sorry.
into 900 or 3, no?
Yes, ma'am, 9.
Sorry, yeah. 30 into, yeah. Variance is 9, fine. So, sigma will be square root of 30 into 9, that means 3 square root 30, is it fine? If I say it as a sigma Sn. Okay, so we want S30 minus 30 into 25 divided by 3 into square root 2. Okay, so probability that my x bar, that means Sn by 30, is lying between 24 to 27, right? That's what we are dealing with, right? Is it fine if I write this like?
Yeah.
Okay, so How to do that? Subtract 25 from both sides, or 25
Yes.
into 30, that is also fine. What? Okay. So we just directly do that things. Is it fine? Just subtract by 25 by 30 and divide it by 30. Okay. So 24 minus what? 25 is then Sn by 30 minus 25 is then 27 minus 25. Okay. Fine. So if I just solve it, I will get Sn minus 25 into 30. Okay, this was my expectations, right? 25 into 30 is mean or expectation, whatever you say. Then 30, this is what? 3. Sorry, 2. Fine. So this is what? Expectation of Sn. That is mean, right? New Sn, whatever you say. We should not say it as a Sn. This is S30. Isn't it? So now 30 is there, and I want denominator as 3 by square root 30. Okay. So it's just probability that I can split it to square root 30, square root 30. Is it fine? Then I will just split like this. Are you getting it or
Yes, ma'am.
not? So this will be mean as 30 divided by what? Square root 30 to square root 30. Fine. So what we need then? Divided by 3. So just 2 at all this place. Is it fine?
Yes.
Oh, that's it. So now this is what? This is probability that our z is lying between what? Minus square root 30 by 3 to 2 by 3 square root 30. Okay. So just calculate these quantities by calculator. You will find that what this value is.
Minus 1.82, ma'am.
Okay, minus 1.82. And what about this one?
3.62.
3.64.
Yeah.
Okay.
I approached.
So this is what? Once we have a probability that z is lying between some value a to b, this is what? How do we write this? Fz of
B minus Z of A.
yeah, f of b minus f of a. Okay, that's it. And were this value given to you? No, the options itself were there, right? So there is a option number A, similar to this. That's all. Okay. Okay. Is there any doubt regarding this particular one? If not, let's discuss the last question. So what is the fourth moment of the normal distribution
Question,
zero? Yeah.
I just need to see the previous question. Just scroll up. I mean, I just wanted to see that. If you could scroll up.
Okay. Previous question.
Yeah.
Yeah. So there was option number 1. That was our solution there.
That solved part.
Yeah. Similar, we solved it like that only. Okay. So actually, no need to write it. You will have this PDF with you after the session. Okay.
Fine.
Okay. So the next one is what is the fourth moment of the normal distribution 0, 9? Okay. Fourth moment you can calculate, right? So in lecture, sir has said that this normal distribution moment, like moment generating function of normal distribution should be on a, like that should be by heart, right? Anyone remember that Sir has said that?
Yes, ma'am.
Yes, ma'am.
Yeah. So if you have listened that, then this is not a big deal now. Fourth moment, right? Okay. So done. So what do we have? It's a normal distribution with mean 0 and sigma square as xi is a, let's say x is a random variable which is a normal distributed with mean 0 and variance 9, right? So here sigma square is equal to 9. Fine. So that mean I can write it as x is following normal distribution with 0 comma 3 square. Fine. Now, so what is the MGF for normal random variable? Anyone knows that?
Lambda square, sigma square by 2.
Yeah, so mx of lambda will be, yeah, what? Exponential of lambda square sigma square by 2. Okay, so that's it. So if this is our moment generating function, in short, we say it as a MGF. So you can just write it as a lambda square 9 by 2. Fine. So how to get fourth moment there? Do you know what's fourth moment? Okay, just expand this series. What will we get? 1 plus, yeah, anyone?
9 lambda square by 2 factorial.
Yeah, into e to the power, no, sorry. Yeah, then next, it's a square, so just square it.
Yeah, 91 lambda power 4 by 3 factorial.
2 square and so on. So what will be our fourth moment there? So the power of lambda denotes the which number moment it is. So
Ma'am.
this is 0th moment, yeah.
Third term will be
Third term.
divide factorial 2.
Yes, 1 by 2 factorial. Thanks. So the power of lambda denotes the number of like is it a first moment or third moment or whatever, right? So this is 0th moment. Fine. This is lambda to the power square, lambda square. That means
Second moment.
one second, and this one is fourth moment. So okay, what is fourth moment then? Yeah, fourth moment will be the coefficient of what?
Lambda square upon 4 factorial. Lambda 4 upon 4 factorial.
Fourth moment of what? Lambda square upon what?
Lambda to the power 4 upon 4 factorial.
Yeah, upon 4 factorial, right. 0.9, right? It's a coefficient of lambda power 4 by 4 factorial. So we have to convert this term into lambda power 4 by 4 factorial. So how to do that? So the term is lambda power 4 into 3 to the power again 4 divided by 2 square, that means 4 into 2 factorial. So what do we need? So 4 is there, 2 is there, 2 factorial is there. Multiply and
divide with 3.
Yeah, that's it. Lambda power 4 into 3 power 4 into 3 divided by 4 factorial. Fine. Once we multiply and divide it by 3, this will become 4 factorial. So that's it. So what's our coefficient then? 3 power 5. Right?
43.
Yeah, 243. That's it. That is our fourth moment for the given distribution. Okay. That is how we calculate moment of any given distribution. So that was all about CLT and moment generating functions. I hope you got the idea how to solve it. That's it. Thank you for today. Any doubt? Yeah, any question on this?
Ma'am, just have a generic doubt. This FZ table anywhere is it available? The standard table is available?
Yes. On Google you will find easily.
Oh, yeah, okay.
Yeah.